Hi, my name is Sadman Binzaman. This is EL6303, assignment 8, question number 1. We're told x is uniform from -2 to 2. So we know that our sketch is going to look, our density function of f of x is going to look, it's going to be uniform from -2 to 2. And we know that that's going to equal 1 over 2 minus -2, so it equals 1 over 4. We're also given that y, random variable y equals g of x, and we're defined from equals 1 from the interval negative infinity less than x less than -1, and that means from the interval -1 to negative infinity we're going to have 1 sustained. From the interval -1 less than equal to x less than 0 we're going to have 1 minus x, so our sketch is going to look something like that. From the interval 0 less than equal to x less than 1, we're going to have -1 plus 2x. So there's going to be a little bit of jump from 1 to -1, and that's going to continue up there with the slope of 2. And then again, from the interval 1 to less than equal to x less than infinity, we're going to have -1. So again, from 1 continuing, we're going to have that equal to -1, and that's going to sustain. So that's our sketch of y equals g of x. Now, to find part A, asking us to find and draw the density of y, meaning small f of y, we need to find what y equals at certain points. So for example, at y equals -1, we're interested in the probability that the random variable y equals -1, which is the same thing as the probability that the random variable x is less than or equal to 1. That equals 1 minus the probability that the random variable x is less than or equal to. That means that random variable, that 1 minus the probability that the random variable x is less than or equal to 1, which equals 1 minus f of x of 1, meaning we're going to have an impulse at y equals -1. Now from the interval from -1 to 1, we're defined by this function, -1 plus 2x. So g of x equals -1 plus 2x for that interval, and the derivative of g of x in that case equals 2. And we know that from the fundamental theorem that f of y equals f of x divided by the absolute value of g prime of x. So we know that f of x equals 1/4 because it's a uniform function, and our g prime of x equals 2. So 1/4 divided by 2 equals 1/8. So for the interval -1 less than or equal to y less than or equal to 1, we have 1/8. Now we look again at when y equals -1, we have that sustained value where it's continuous. That means again we're going to have an impulse there, but now we need to find the weight of that impulse. So at y equals 1, we have the probability that y equals 1, which is the same thing as the probability of the random variable x being less than or equal to -1, which equals f of x -1. So that's our weight for that impulse. And the last thing we're interested in is the region from 1 to 2, and that's defined by the graph, by the slope of, by the line y minus x. So from the interval of 1 less than or equal to y less than or equal to 2, we know that we're defined by g of x, which equals 1 minus x, and we know that the g prime of x, the derivative of that, equals -1. So to calculate fy, we can use the fundamental theorem, which is f of x divided by the absolute value of g prime of x. Again, since we're dealing with a uniform function, our f of x is going to be 1/4, and like we mentioned earlier, our g prime of x is -1, but we're interested in the absolute value, so 1/4 divided by the absolute value of -1 equals 1/4. So to summarize, at f of y, the density function of y is written out as 1 minus capital F of x of 1 for y equals -1 equals 1/8 for the interval -1 less than or equal to y less than or equal to 1 equals capital F x of -1 at y equals 1, and 1/4 for the interval 1 less than or equal to y less than or equal to 2. And our sketch of the density of y looks something like this. So we have impulses at -1 and 1, and the impulse at -1 has a weight of 1 minus fx of 1, and the impulse at 1 has a weight of fx of -1. Part 2 of the question asks us to find and draw big F of y, or the distribution function of y. So we're going to look at it graphically. We know that we know that at y equals -1, we're going to be defined by that impulse, which has a height of 1/8, So we're going to bring our line up to 1/8, and then for the interval from -1 to 1, we're defined by the slope of that 1/8. So we have a slope of 1/8. And then again, at -1, we have another impulse with a weight of fx of -1, which in other words is going to be 1/4. So we go up by 1/4. So now we go up now we're at 3/8. And then at 1, we're again be defined by that slope of 1/4. So we're going to go up by a slope of 1/4. And then when we hit y equals 2, we're going to sustain.